Use the method of Lagrange multipliers to find the volume of the largest rectangular box in the first octet with 3 faces in the coordinate planes and 1 vertex in the plane 2x plus y plus 4z equals 24. In class we did a problem exactly like this, and so we can work this out. We have the coordinate planes, and then we have a box. Well, this plane here will intersect the axes at different places. It'll intersect the x-axis when x is 12, both y and z are 0. It'll intersect the y-axis when y is 24. It'll intersect the z-axis when z is 6. And so what we have is this plane here. We're going to have a box that will have 1 vertex on this plane, 1 vertex on this plane, and then we basically have the coordinate planes as 3 of the faces of the box. So it would look something like this. Okay, now Lagrange multipliers. So we have a function f that we are to maximize. It is the volume of the box. And that volume will have coordinates x for the length, y for the width, and z for the height. Oh wait, in class we didn't do this as a Lagrange multiplier. This is good. And so the constraint is that we have to be, the relationship between x, y, and z has to be such that 2x plus y plus 4z minus 24 is equal to 0. And that's our constraint. It's our function we are to maximize. And so we take the gradient of f and set it equal to lambda times the gradient of g. The gradient on f is yz for the x component, xz for the y component, and xy for the z component. The gradient on g, numerical, each component 2, 1, and 4. So the gradient on f has to equal lambda times the gradient on g, and then that's going to mean that we have to solve 3 equations. They are that, on the one hand, yz is 2 lambda. On the other hand, xz is lambda. And thirdly, xy is 4 lambda. Your job is to get a relationship between x, y, and z that you could plug into the constraint from these 3 equations. And so we just do some combining. We have these first 2 combined. Say that say that yz is twice xz. And so we can, it's tempting to cancel the z's out. We'll explain why we want to be careful with that. We'll have yz minus 2xz equals 0 and factor out the z, and have y minus 2x multiplied by z is equal to 0. Z can't be 0. You wouldn't have a box at that point. And so since z can't be 0, it must be that y is 2x. And we can do the same thing here to get z as a function of x. We have xy is 4 times xz. And we'll get that looks like xy is just twice yz. The goal is to get yeah, well, this gives us xy minus 4xz is equal to 0, or that x times the quantity y minus 4z is equal to 0. So y is 4z. And you know what? That's actually enough. Yeah, we'll have to take the fraction version of these guys. X is half of y, and z is a fourth of y. And we take all that together and plug it into the constraint. That 2 times x, half of y, plus y, plus 4 times z, a fourth of y, is equal to 24. And so we get the cancellation nicely to give us 3y is 24. Or that y is 8. And if y is 8, then x is half of that, 4, and z is a fourth of that, which is 2. So our point is 4, 8, 2, and the volume is going to be the product of those three numbers, which is 64. So that is the answer to the question, 64 units cubed.